Students, so we have already introduced light in the preceding lecture. So and also you people must be aware of the laws of reflection. Actually, reflection is the bouncing back or returning back of light back to the same medium when light is incident on a certain surface. And there are two laws governing the laws of reflection, which you all must be knowing from your class 9 itself. Now, when a ray of light, you can see when a ray of light is incident on a surface, that light ray does not go to another medium, but it gets bounced back in the same medium. This is called reflection. That is how you see your image in the mirror, isn't it? So, the angle which this ray is called the incident ray, and this ray is called the reflected ray. Okay, the angle which the incident ray makes with the normal is the angle of incidence, and the angle which the reflected ray makes with the normal is the angle of reflection. This everyone knows, I suppose, because this is just a recapitulation. Now, there are two laws governing the laws of governing reflection. First of all, this angle I and this angle R are exactly equal. That is, angle of incidence is equal to the angle of reflection. And the other one is fairly simple. These the incident ray, the reflected ray, and the normal, and this O is called the point of incidence. They all lie in one plane. You understand the plane, isn't it? Three-dimensional. I am talking about the 3D. Okay, they all lie in. Suppose an incident ray, a ray is incident here, so the reflected ray and the normal will also be, they will all lie in a particular plane, three-dimensional. Okay, they all lie in the same plane. Now, in your syllabus, this plane mirror reflection and all this you have been doing from the junior classes itself. But in your syllabus, they have told you to know about spherical mirrors. Okay, so spherical mirrors means they have a curved, structure. So if they have a curved structure, basically you must be acquainted with these words concave and convex, right? So spherical mirrors are of two types. One is concave and the other is convex. Now, concave mirror, so this is the reflecting surface, and this is the non-reflecting surface. Okay, non-reflecting. That means the reflecting surface lies, towards this side. I have made a mistake here. Okay, towards the inner side. So what does this mean? This means this spherical mirror can be considered as a part of a sphere. Okay, had it been a sphere, it would have been appearing like this. Okay, it's not a perfect sphere, but try to manage. Whose center would lie somewhere here, isn't it? So here, let's write it will be somewhere here. So now, before going into the details of these spherical mirrors, you got to discuss about some technical terms associated with it. So, had this been a complete sphere, okay, the center would have been somewhere here. So this center is called center of curvature. Okay, technical term, center of curvature. Now, a line passing through the center of curvature and the pole. What is pole? P is called the pole. Pole is the center of the curved surface that we have considered. This is the curved surface. More or less the center is here. So P is called the pole. Now, the distance of the center of curvature from the pole is called radius of curvature. Radius of curvature, that is R. Is this okay? Now this is a concave mirror. When light ray comes and hits this concave mirror, the reflecting surface, as I have said, is towards the inner side. So when light ray comes and hits this concave mirrors are converging in nature. Okay, converging. That means light ray will come towards a point. It will converge. It will meet to a point. So it will come and meet at some point. Suppose light rays are coming from infinity, or later we'll discuss about different cases. So it will meet at some point. Okay, My diagram is not so perfect, but still light is incident on the reflecting surface of the concave mirror. It gets converged towards a point. Okay, for example, here you can see here it is getting converged. Light ray is coming from here, it will get converged at this point. Are you understanding? So the point of convergence, for the time being, let us consider this to be F, and this is called focal point, or sometimes called focus. Okay, so the distance of this focus F from the pole, that is FP. Okay, this is called focal length. Okay, is this okay? Now the same thing can be analyzed for a convex mirror also. Okay, now let us analyze for a convex mirror. Now here convex mirror means the same thing can be considered. It is a part of a sphere where C will be the center of curvature, P will be the pole, this will be the principal axis, pole, center of curvature. When light ray is incident on the, now you can see reflecting surface is on the outer side, that is the center of curvature lies towards the non-reflecting surface in case of a convex mirror, convex. Okay, and it is diverging in nature. It is just opposite to that of a lens, you will see later. Actually convex mirrors and concave lenses, they have same type of properties, and concave mirrors and convex lenses, they have same type of properties. So when light ray is incident on the reflecting surface of the convex mirror, it gets diverged away from a point. Okay, similarly light ray is incident on the reflecting surface, so it gets diverged, okay, away from a. Now as it is getting diverged, let us draw it here, it is getting diverged, we can produce it backwards. Okay, and they meet at this point, isn't it? They meet at around this point. Now basically this distance is called your focal length, and this distance is called your radius of curvature, and you saw it for a convex mirror, concave mirror also. So basically what we have discussed is concave mirrors, they are converging in nature, and convex mirrors, they are diverging in nature. There is a center of curvature in each case, there is a pole, there is a principal axis, the axis which passes through the center of curvature. The distance of the pole from the center of curvature is called radius of curvature, and the distance of the pole from the focal point F, that is the point where the final light ray they meet, or they appear to meet. It appears as if the light rays are coming from this point, isn't it, if you produce it backwards in this case. So this distance FP is called focal length. One very important point to remember is F is equal to R by 2. That means the focal length is half of the radius of curvature. That is, this distance is half of this distance. This is a very, very important point which you need to remember. Okay, so here we have discussed about some technical points related to spherical mirrors. Next, what we'll do is we'll talk about image formation in different cases when the object is placed at different positions in the next class. So till then, see you, stay safe, thank you.